Hello, hello. Good night, everybody. How are we doing? It's the start of a new week. New week, new videos for programming. How's the weekend? My weekend was good. I'm going to turn my little heater on. Hold on a second. There we go. My weekend was good, uneventful. Watched Across the Spider-Verse with my wife and family on Saturday, and that was a really good time. Then on Sunday, I served. I ran a camera, which was good. And other than that, just chilled and stuff like that. And I finished Attack on Titan last night, which is also very, very good. And today I finished I've been watching a lot of stuff. I finished The Patient with Steve Carell and I'm blanking on his name, but the guy that played General Hux, I think it was General Hux from the Star Wars sequels. But yeah, so that was all good. But we are back at it with learning Python, 63% through, and we're just gonna jump on into it, agreeing on a wire format. I don't know. Okay, without further ado, let's get into this.
Hello and welcome to
Oh shoot, this is only 2 minutes long. It was like the shortest video we've ever seen.
Chapter 13, Web Services. So what we've been doing so far is
data on the web with the HTTP request response well understood and well supported. Oh, okay, understood overall. He's not saying that we understood it. Like, we understand it at this point. Like, well understood in general and well supported. There was a natural move toward exchanging data between programs using these protocols. Okay. We needed to come up with an agreed way to represent data going between applications and across networks. There are two commonly used formats, XML and JSON.
we've been using the request response cycle. We've learned about sockets, we've learned about URL lib, and we've actually learned how to pull HTML and even flat text off the internet. But what we're going to talk about now is using that same request response cycle to retrieve information that is specifically designed for programmatic consumption, so that, you know, we had to have this beautiful soup which sort of did a hack job or solve the hard problem of parsing HTML. But why not produce data in a format that makes good sense to a program, because programs want to talk to each other? If you recall, the whole idea of a socket is to have one application process.
Sorry, I bit a mustache hair off out of my mouth. Sending data across the net. PHP array, Python dictionary, JavaScript object, Java hash map, aka wire protocol, what we send on the wire. Name, chuck, phone. See, these are different ways of yanking data from the net or sending it. Okay, so it could be like from a Java hash map to Python, or from a JavaScript object to a PHP array, and this could be the info.
Sending talk to each other. If you recall, the whole idea of a socket is to have one application process sending data to another application process. And so if we think about this problem of parsing HTML, but why not produce data in a format that makes good sense to a program, because programs want to talk to each other? If you recall, the whole idea of a socket is to have one application process sending data to another application process. And so if we think about this for a moment and we realize that we have all these programs, they could be written in different programming languages and they're all connected. And so they might want to send data back and forth through the network. PHP programs, JavaScript programs, Java programs. And so we have to decide on a protocol that is independent of any programming language. And we call that the wire protocol, because if you were to sort of take some connection and watch the exact characters that go back and forth, that's what you would see if you were monitoring the wire. So that's why we call that the wire protocol. And so the idea is that we have to agree on a format that is going to represent the
Serialized, deserialized. So is this kind of like encoding, decoding? In XML? Person name, truck name, phone, person.
data, and we can't make it a Python specific format or a Java format. And when we take the data from the internal representation, maybe a Python dictionary, to send it to the wire, we call that act serialization, and that is going from sort of the internal representation to the serial representation or the wire representation. And then here is an example of a person with a name and phone number with using less thans and greater thans. This is an XML example. And then in the far end, in a different programming language, it receives this and then deserializes it and then turns it into some useful structure inside that programming language. And so this is an example of a wire protocol that's using XML, and that's one of the formats we're going to talk about. Another format that we're going to talk about is a format called JSON, JavaScript Object Notation, and it is simpler and easier, but it's not as another format.
So that, wait, hold on. This is HTML, or excuse me, HML? XML, excuse me. This is XML.
Talk about.
And that's JSON.
Another format that we're going to talk about is a format called JSON, JavaScript Object Notation, and it is simpler and easier, but it's not as precise and descriptive as XML is. And so while you'll find that most of the things you run into, especially if you're talking to APIs of one form or another, you'll find that JSON is very common. XML still holds sway in places like documents. So if you look at docx at the end of a Microsoft Word document, docx means that it's an XML version of the representation of a word processing document. So the first thing we'll talk about is XML. Hello and welcome to Microsoft Word document. Docx means that it's an XML version of the representation of a word processing document. Of the representation of a word processing document. Docx means that it's an XML version of the representation of a word processing document.
That's confusing. Hold on.
This means that it's an XML.
Okay, I'm sorry. I was looking at my phone. I need to step away a moment. So bear with me here. I will be right back. Okay, we're back. For those of you who don't, I mean, for everybody, that transition that just happened with the slicing across and everything, and that pausing screen was actually my gaming channel's pausing screen and the transition and all that. I've got both. Excuse me, goodness. I've got a set of stuff for this channel and a set of stuff for my gaming channel, and I can't. I went to the wrong pausing screen just on off the rip, but then the transition, I can only have one transition at a time. I don't usually transition stuff anymore for this channel, but I needed to for this. So all right, where were we?
XML still holds sway in places like documents. So if you look at docx at the end of a Microsoft Word document, docx means that it's an XML version of the representation of a word processing document.
The whole representation thing is confusing to me. It's a XML version of a document.
At the end of a Microsoft Word document, docx means that it's an XML version of the representation of a word processing document.
Okay. I want to move forward. Even though I don't, my brain isn't fully wrapped around that concept, but that's okay. Marking up data to send across the network.
So the first thing we'll talk about is XML.
All right. The two most common ways to send data over the internet. We're going to go with JSON and XML. 64%. All right.
So,
what is wrong with the following XML? So we're straight learning XML? Is this a language? No. I'm sorry for those of you who actually know more, are just shaking their heads no, it's the dude just told you it's not, or something like that. Because I've seen, me, I'm a video editor. I'm very familiar. I've seen many XML files. I just never really knew it from this point of view, All right.
So one of the two ways that we mark up data is XML. The other.
So it's not a language. It's just a way of marking up data, I guess.
JSON. First, we'll talk about XML. We'll talk about XML more for a longer time than we talk about JSON.
Extensible markup language. Oh, it is. Oh, it is a language. XML. Oh, I was right. Primary purpose is to help information systems share structured data. It started as a simplified subset of the standard generalized markup language, SGML, and is designed to be relatively human legible.
XML stands for Extensible Markup Language. There was a number of markup languages in the 90s that were out there, ways to send data between computers, and none of them was amazingly better than the other, but in the early 1990s, as HTML came out, the idea that we could use less thans and greater thans, or angle brackets, some people call them. Once HTML made angle brackets popular as a representation format, it was pretty natural that we would find a data representation format that would take a similar approach. And so inside
XML terminology tags indicate the beginning and ending of elements. Tags indicate the beginning and ending of elements. Attributes, keyword, value pairs on the opening tag of XML. Keyword value pairs on the opening tag of XML. Serialize, deserialize, convert data in one program into a common format. that can be stored and or transmitted between systems in a programming language in a programming language independent manner.
XML, we're going to talk about tags, we're going to talk about attributes, we're going to talk about data, and we've already talked about serialization and deserialization. Serialization is the act of taking data inside of a computer in one programming language, setting it up for transport, transporting it across, and then taking it back apart and turning it back into the data in whatever internal data it needs to be in the destination system. So here's some basic XML, so we can take a look at the various things that make up the XML. So it's very much like HTML.
Okay, so start tag, person, name, text content, Chuck, end tag. Okay, so these are start tags, end tag, start tag, attribute, type. Don't know what INTL stands for, and then that's the actual data, the text content, that's the end tag. Self-closing tag, what the heck is that? So I just close itself, that's the type, or the attribute, excuse me, that is the end tag.
And that we have tags, less than, greater than. The difference is we get to name the tags anything we want rather than the A tag or the P tag or the H1 tag. And there's a beginning tag and an ending tag, and they're bracketed together. And there's syntax errors in XML. Syntax errors in XML are more severe than syntax errors in HTML. It's supposed to be right, and if you send bad XML, it's likely that the far end will not understand it. So we have a likely that the far end will not understand it. So we have a beginning tag and ending tag, and so like name and slash name are a beginning.
I think you meant like like a for loop, like for in, or foreign, like a foreign language. I don't know.
An ending pair, tag and ending tag, and so like name and. If you send bad XML, it's likely that the far end will not understand it. So we have a beginning tag and ending tag, and so like name and slash name are a beginning and ending pair. Then there is the actual textual content, and that is the material between it. And then here's a phone and slash phone, and we have this thing called the attribute. Key equals value. The key doesn't have double quotes. The value always has double quotes. And this key doesn't have double attribute. Key equals between it. And then here's a phone and slash phone, and we have this thing called the attribute. Key equals value. The key doesn't have double quotes. The value always has double quotes. And this is like href equals on an anchor tag. And sometimes you have what's called a self-closing tag, where you don't actually have a closing tag. You have all the data that you need in the attributes. And
oh. So slash is the end tag? Yeah. Or slash, like, whatever it is.
So you don't even bother putting an empty text area in a closing tag.
Excuse me.
So that is a start tag, an end tag, attribute, and then a self-closing tag. Those are some basics of XML. In
Jeepers, white space. White space line ends do not matter. White space is generally discarded on text elements. We indent only to be readable, so it's for our benefit. Person, name, Chuck, name, so that wraps that up. Phone tells us the attribute, the text content, and whatchamacallit, tag, self-closing tag, and tag. I'm learning this. Person, what's this? Name, Chuck name. What is this? Greater than.
general, XML doesn't care too much about white space. It does in the text areas, so in here it matters and here it matters, but things like we can indent this a little bit differently, and we tend to indent it in a way to make it look reasonable. Although once you have programs sending it back and forth, they tend to send it more compacted just for efficiency purposes. So,
wait, he never talked about that. Oh, that was just simply to talk about the indenting. Person Because I don't know what this is. Type greater than the phone. Yeah, I don't get that.
Purposes. That more compacted just for efficiency purposes.
XML elements or nodes. Person. So simple element, name, check name, or excuse me, phone, content, phone, end tag. What? Oh, so this is the node. It's like inside person, because that's a beginning tag, that's an ending tag, and that's like a tag within a tag. A simple element. Complex, so person, name, no name, which is the same. What? That's the same. What?
So one of the concepts is that there is a hierarchical structure within an XML document, and there are parent nodes and child nodes, and you can think of these as simple nodes that is a tag in some data, or a complex element that has a tag that includes other tags. Is a tag in, you can think of these as simple nodes that is a tag in some data, or a complex element that
isn't that that's a tag. This is a tag and a tag.
Has a tag that includes other tags, some child tags. And there's a couple of different ways we can take a look at this. That includes other.
Okay, so these are identical. Call me stupid now. But these are exactly the same. Name. So you got person, indented, name, check name, or name, blah blah, name, blah blah, name. Why?
Tags, some child tags. And there's a couple of different ways we can take a look at this.
Elements, text.
The simple and more natural way to think about this is a tree with parent-child relationships. So here we have this A tag on the outside, and that's the top level one. You can only have one outer tag, and you can't have another tag down here. So you have to have one tag that's sort of the root tag for everything in this XML document, and it has two children. So the C tag and the B tag are two children. So the B tag is a child of A, and then C has a D and an E tag that are children there, and then the textual data we model as a child of each of those tags, and you'll see in a bit why it's best to do that. So that is the way to think about this as a tree, to represent that XML as a tree. If we add attributes to it,
it's just another child.
And this is where you kind of see why it's nice to take the text area and make that be a child of the node. An attribute is a different. So the text is it's nice to take the text area and make that be a child of the node. An attribute is a different. So the text is a special kind of child, and you can literally have more than one attribute. You could have x equals 2, zap equals whatever, and these could have a couple of different attributes. The W attribute is a value of 5, and that's the 5 down there. And so you could have multiple ones. You can only have one text node. Now,
what?
5 down there, and so you could have multiple ones. You can only have one text node.
Oh. Okay, I didn't know that. Can these have children? Probably not, if I had to guess.
Now, in the case of A, you have a whole bunch of text nodes, but these are because there are child nodes. Within one simple node, you can only have one text element. You can
Okay. Smells paths. What? A, B, X. A, C, D, Y. A, C, E, Z. Okay.
also think of XML as paths, and the easiest way is to sort of look down this tree version and look at from the path from the parent. So you go to A, then the child B, and then X. So at position AB, you find X. So AB is the path up to the root. So ACD, that's this one, is the path to Y, and ACE is the path to Z. And so you can think of these as paths. Part of what we're doing is we're coming up with ways to walk through and parse trees of XML data. So then ways to the path to Z. And so you can think of these as paths. Part of what we're doing is we're coming up with ways to walk through and parse trees of XML data.
Trees of XML data. Okay.
So the next thing we'll talk about is how we determine if a particular XML document is legal or meets the contracts that two applications have set up.
And that was XML schema describing a contract as to what is acceptable XML.
Meets the contracts that two applications have set up.
Okay. All right. Cool. I think I understand. What is wrong with the following XML? Person, name, Chuck name, phone, then the attribute, and then da-da-da. Oh. Email, hide, yes, and that's the self-closing thing, email. There's no ending email. No, phone is missing a closing tag. Heck yeah, dude. 66%. All right. That, excuse me, it's going to do it for tonight, I think. Yep, that's going to do it for tonight. Dipping our toes in XML. I feel pretty good about it. Good start to the week. Thank you guys so much for watching. If you enjoy this sort of content, feel free to like and subscribe if you want to see more of it. Leave a comment below if you have a prayer request. I would love to know how I can be praying for you guys. But in the meantime, love God, love people, and I will see you guys soon.